So work problems. This is an application to solving equations, particularly with fractions. One way to look at these is kind of use a formula. And this is specifically when we're talking about to determine how much time it takes to determine the time it takes to complete a job with combined effort. So one way to look at this with a formula is 1 over time A plus 1 over time B plus dot dot dot. If there's multiple things that we're combining to work together, equals 1 over time together. Okay, so the A and the B and the so forth, these are the individual efforts. So whether it's people or a machine, individually how long it would take them, and then the fraction by itself, the time on the bottom, is the time it takes together. Okay, so for example, if we have one machine can mill a set of parts in 90 minutes. Another machine can complete the job in 50 minutes. How long would it take if they both were working on the parts? They both were working on the parts. So first let's kind of estimate and use some logic. Let's say both machines were working at a rate of 50 minutes if they did it individually. So if they both were could take 50 minutes alone, well, if you had them both working, it would be half the time. It'd be 25 minutes. But the other machine's a little slower. So let's estimate like, maybe about half an hour, about 30 minutes. Regardless, it should be quicker. If they're working together, it definitely should be quicker than 50 minutes. So using this formula, if I did 1 over, the first machine takes 90 minutes alone, plus 1 over, the second one takes 50 minutes alone, equals 1 over the time together is what I don't know. So we'll call it x. Could use t or x. Okay, so common denominator between 90, 50, and x. So just think about like 9 and 5 would be 45. So it's going to be 450t. So multiply that over 1. 450t over 1 to this fraction, and then 450t over 1 to that one. Oh, and I'm mixing up my variables. I said x at first, and then I started using t. We'll switch it to t for time. Okay, so when I do my reducing, 45 divided by 90, I'm going to be left with 5. 50 divided by, 450 divided by 50, I'll be left with 9. And then the t's will cancel on the last one. So I'll be left with 5t plus 9t equals 450. So now I don't have any more fractions, so I can combine 5 plus 9 is 14. 14t equals 450. Divide by 14. Let's see if we get our close to our estimate that we had said, and this comes out to 32.14 minutes, so pretty close to our estimate. Okay, so the reason this works out is it's like a inverse fraction because the time is also doing an inverse reaction. It should be, as you have more things working on a job, it should take less time. Now let's do one more, because sometimes too, if we have something working against the others, then we're going to have to subtract the fraction. Okay. So if something is working against the others, subtract the fraction instead of adding, like we have the formula set up. Okay, so what I'm talking about, where this could happen, something like this. A tank has 2 pipes entering it. Has 2 pipes entering it. They take 3 minutes and 7 minutes to fill if filling alone. So if only the first pipe is open, it takes 3 minutes to fill. If only the second pipe is open, it takes 7 minutes to fill. Another pipe drains the tank and takes 21 minutes to empty alone. So this is kind of assuming the other pipes are not going, or not open. How long would it take to fill the tank if all pipes were open? Okay, so the ones that are filling, those are going to be added. So 1 over 3 plus 1 over 7. And then the emptying is working against it, so that's subtracted. Minus 1 over 21 equals 1 over the total time, if all 3 were going. So in this one, 3, 7, 21, and t, common denominator is going to be 21t. So 21t over 1, 21t over 1, 21t over 1, 21t over 1. So I'm going to go through and do my canceling. 21 and 3, I'm left with 7. 21 and 7, I'm left with 3. 21's cancel, t's cancel. So I'll be left with 3t plus 3t minus t equals 21. 7 and 3 is 10, minus 1 is 9. 9t equals 21, divide by 9, and I get, this would be 2 1/3 minutes, 2.33 minutes. Now the one, we're not going to do another example of this, but I just want to point out too, let's say we knew what the total time is and we just don't know what one of them working alone is. We would set up the same way, we just would have a variable on the other side and we know the total time. So it could work that way too with these problems.